Welcome to another deep dive. Today we're setting our sights on everyone's, favorite red neighbor, Mars.
It's a classic.
It is. And more specifically, its surprisingly complex relationship with water. You've sent over a whole stack of research about the history, the presence, and even the future possibilities of water on Mars. We're talking like ancient oceans, hidden glaciers, and maybe even, just maybe, some clues about life beyond Earth. So are you ready to trade your spacesuit for a comfy chair and embark on this journey with us?
Let's do it.
Buckle up. Now I know what you're thinking. Mars, that dusty red, seemingly lifeless planet, where's the water? But that's where it gets really interesting, right? Turns out the Mars we see today, well, it might just be a snapshot in time, a far cry from its younger, wilder days.
That's right. The evidence you see, it suggests that billions of years ago, Mars wasn't the dry, desolate world we know today. It might have been a planet teeming with flowing rivers, vast lakes, and even oceans that, get this, dwarfed Earth's Arctic Ocean.
Okay, stop. An ocean bigger than Earth's Arctic. That's mind-blowing. But how do we know this wasn't always just a giant, dusty desert? What clues point to this watery past?
Just imagine looking at Mars from space. What you'd see etched across the planet's surface are these telltale signs, massive canyons, dried up riverbeds, and what look a lot like, well, ancient coastlines. They're like giant planetary scale fossils whispering tales of a much, much wetter time.
These fossils, are they visible from space? Because, from Earth, Mars just looks like, well, a red dot.
Oh, absolutely. We're talking about features so massive they can be seen even with relatively simple telescopes. But to really appreciate the detail, we turn to our high-tech eyes in the sky. Satellites equipped with high-resolution cameras.
So we're talking about looking at photographs to uncover Mars' watery secrets.
Not just photographs. Think sophisticated imaging techniques. These satellites don't just see what we see. They can sense subtle variations in elevation, mineral composition, and even, believe it or not, gravitational pull. All of these things give us clues about what lies beneath the surface and what that surface would have looked like millions, even billions of years ago.
It's incredible to think that these subtle variations, these whispers from the past, can tell us so much about Mars's history. But those are just hints from afar, right? What about, concrete evidence? Did these Martian rivers actually flow with water?
That's where the real detective work comes in. Our robotic explorers, the rovers like Spirit, Opportunity, and Curiosity, they've been scouring the Martian surface for years now. And what they've unearthed is, well, it's remarkable. We're talking about minerals, specific types of minerals that only form in the presence of liquid water.
So it's like finding a rusty old fishing rod on a seemingly dry lake bed, proof that there was at some point definitely water there.
Exactly. These mineral discoveries, they act like time capsules, they offer irrefutable evidence that liquid water once flowed on Mars.
This is incredible. We've gone from a red, dusty dot in the sky to evidence of a planet with flowing water. But if water was once so abundant, what happened? Why did Mars dry up?
That is the big mystery, isn't it? The prevailing theory suggests that Mars experienced a dramatic climate transformation. You see, unlike Earth, which has a strong magnetic field acting like a shield, Mars lost its protective barrier billions of years ago.
So no more magnetic field to protect it. What happened next?
Well, without that shield, the solar wind, which is a constant stream of charged particles from the sun, was free to strip away Mars' atmosphere. Over time, this process, it thinned the Martian atmosphere, causing it to lose most of its water vapor and leaving behind the cold, arid planet we see today.
Wow, so Mars went from potentially habitable to a dry, desolate wasteland. It's a stark reminder of how delicate planetary environments can be. But even though Mars lost most of its water, our sources suggest there's still some hanging around today, right? It's amazing to think that even after this dramatic climate shift, Mars still, clings to some of its watery past. So where exactly is all this Martian water hiding today?
Well, let's start with the obvious. The Martian polar ice caps. Those bright white crowns you see in pictures. They're not just for looks.
I have to admit, I always thought those were just frozen carbon dioxide, like dry ice.
They do contain some dry ice, sure. But what's really exciting is that, a huge portion of those polar caps is actually water ice, just like what we have, here on Earth. And we're not talking about a few, measly glaciers here. These ice caps are massive.
Okay, so how massive are we talking? Give me a sense of scale here.
Imagine this. If you could somehow melt all the water ice trapped in those polar caps, it would be enough to submerge the entire planet under 35 meters of water. That's about the height of a 10-story building.
Wow, 35 meters. That's a lot of water. You know, it makes you wonder what other secrets Mars might be hiding beneath its surface. Could there be, say, liquid water lurking somewhere, underground?
You're thinking like a true Martian explorer, and the answer is, well, a resounding maybe. We have good reason to believe that Mars harbors vast reserves of water ice just below its surface, hidden from the harsh conditions above.
So how do we know this? Are we relying on our rover buddies to dig down and find it?
The rovers are great, but for this we need to bring in the big guns, so to speak. We use something called ground penetrating radar, which is a bit like using X-ray vision to see beneath the surface.
Hold on, we're using radar on Mars. How does that even work?
It's pretty ingenious, actually. We have these orbiting satellites that beam radar pulses down towards Mars. These pulses can penetrate the surface, and when they hit something like a layer of ice, they bounce back up to the satellite. By analyzing the time it takes for the signal to return and how strong it is, scientists can create a map of what's hidden beneath the surface.
Okay, that makes sense. So it's like those ultrasound machines doctors use, but instead of looking inside a human body, we're peering beneath the Martian surface. And what have these radar scans revealed?
Well, we found these bright reflections in the radar data, especially in the Martian polar regions. And guess what those bright reflections usually mean? Ice. Lots and lots of ice. Some of these deposits are thought to be just a few meters below the surface, making them, potentially accessible for future missions.
This is incredible. We're talking about potential reservoirs of water just waiting to be tapped. But what about liquid water on the surface? Is that completely out of the question? Could there be a hidden Martian oasis out there somewhere?
It's a long shot, but here's the thing about Mars. It loves to keep us guessing. Remember how we talked about those harsh surface conditions?
Yeah.
The thin atmosphere and the freezing temperatures?
Yeah, it didn't sound very hospitable for liquid water.
Exactly.
Yeah.
But despite all that, we've observed these puzzling features called recurring slope linea, or RSLs for short.
RSLs, those ring a bell. Aren't they those dark streaks that sometimes appear on Martian slopes? I remember seeing pictures that kind of look like ink splattered on a hillside.
That's them. These dark streaks appear seasonally during the warmer months and seem to flow downhill, almost like dark narrow rivers.
So are these RSLs proof of liquid water flowing on the surface of Mars today?
That's the million-dollar question, isn't it? And the answer, at least for now, is we're not entirely sure. Some scientists believe these RSLs are caused by briny water with a high salt content, which allows it to remain liquid even at very, very low temperatures.
So like super salty water.
Exactly. Think of it like the Dead Sea on Earth, but on Mars. Others suspect that the RSLs might be caused by dry flows of sand or dust, kind of like mini avalanches triggered by the changing temperatures. More research is needed to say for sure, but the possibility, even the slight chance of liquid water on Mars today it's incredibly exciting.
It's like Mars is holding out on us, giving us these tantalizing hints, but not quite revealing all its secrets just yet. So we've gone from ancient oceans to massive ice caps, hidden underground reservoirs, and even the possibility of salty streams. It's clear that the story of water on Mars is, it's far from over. But what does it all mean? Why should we here on Earth care about water on a planet, millions of miles away?
That's a great question, and it gets to the heart of why we explore space in the first place. You see, the implications of water on Mars, both past and present, they're huge. They touch upon some of the biggest questions we have about our place in the universe, the search for life beyond Earth, the future of human exploration, and even, believe it or not, understanding our own planet's past, present, and future.
Okay, so let's unpack these implications. First up, the one we've all been waiting for, right?
The big one.
Exactly. If Mars once had, rivers, oceans, maybe even a climate similar to early Earth, could there have been, Martians?
It's the question that, it drives so much of Mars exploration, and the truth is we just don't have a definitive answer yet. But the possibility, it's incredibly tantalizing. We know that water is, It's absolutely essential for life as we know it. And given Mars's watery past, it's certainly plausible that microbial life at least could have arisen on the red planet at some point.
And this is where it gets really like mind-boggling. That life, if it ever existed, might not be just a thing of the past, right? It could still be like hanging out today, tucked away in those underground water reserves we talked about.
Exactly. Now, I know that it sounds like something out of a science fiction movie, but hear me out. These subsurface reservoirs, if they exist, could offer a stable environment, shielded from the harsh radiation and wild temperature swings on the surface. It's not exactly a tropical paradise, but it could be enough for some hardy microbes to survive.
So are we talking about like finding little green men down there, or something more along the lines of, microscopic critters?
Think smaller. If life does exist on Mars today, it's most likely in the form of simple single-celled organisms, similar to the earliest forms of life on Earth. And finding evidence of even microbial life on another planet would be, it would be absolutely groundbreaking. It would completely change our understanding of life in the universe, proving that we're not alone.
That would be incredible. It would be like that moment when we first, discovered there were other planets orbiting other stars, a whole new perspective on our place in the cosmos. But how do we go about finding these elusive Martian microbes? We can't exactly send a deep sea submarine down there.
Not yet, anyway. So we've got some brilliant minds working on it. I'd say one of the most promising avenues is the Mars Sample Return Mission, a joint effort between NASA and the European Space Agency.
Okay, remind us again, what's so special about the Mars Sample Return Mission?
Well, as the name suggests, the goal is to bring pristine samples of Martian rock and soil back to Earth. This is huge because it would allow scientists to analyze these samples with the full power of Earth-based laboratories, something we could only dream of doing with our current rovers.
So we're talking about like bringing a little piece of Mars back to Earth. What's the timeline on that? When can we expect these Martian care packages to arrive?
The current plan is to launch the mission in two stages. The first launch, scheduled for 2026, we'll send a rover to collect those precious samples. Then a few years later, another spacecraft will launch to rendezvous with the rover, grab the samples, and bring them back to Earth sometime in the early 2030s.
The early 2030s, so potentially less than a decade away from getting our hands on pristine Martian samples that could hold evidence of life beyond Earth. Amazing, but alien microbes are fascinating and all. But let's talk practicality for a moment. What about water as a resource for future human explorers? We're talking about sending humans to Mars in the coming decades. Surely having access to water on the red planet would be a game changer, wouldn't it?
Absolutely. Think about it. Water is, it's essential for survival, obviously, but it's also heavy, incredibly heavy, to launch from Earth and transport across millions of miles of space. If we can find ways to utilize the water resources already on Mars, it would revolutionize human exploration.
Right. Imagine not having to haul all your drinking water, water for growing food, or even water for producing like rocket fuel all the way from Earth. But how feasible is it to actually to access and use this Martian water, especially those vast reservoirs trapped beneath the surface?
It's definitely a challenge, but not insurmountable. Extracting water ice from beneath the surface will require advanced drilling techniques. Imagine having to design a drill that can operate in the extreme cold and thin atmosphere of Mars. And then there's the energy required to melt that ice into usable water. It's a complex engineering puzzle, but one that's well worth solving.
Okay, so we've covered the past and present of water on Mars and hinted at its potential role in our future. But I want to circle back to something you said. You said earlier, you mentioned that studying Mars, especially its water history, can teach us about our own planet. What did you mean by that?
That's one of the most fascinating aspects of this whole story. You see, Mars and Earth, they started out remarkably similar, at least in terms of their potential for life. But somewhere along the way, their paths diverged, diverged dramatically. Mars lost its magnetic field, its atmosphere thinned, its water disappeared, and it became the cold desert world we know today.
Whereas Earth, well, Earth flourished. It became a haven for life with vast oceans, lush forests, and eventually, well, us.
Exactly. By studying what happened on Mars, by understanding the factors that led to its dramatic climate transformation, we can gain invaluable insights into the delicate balance that makes Earth habitable. It's like holding up a mirror to our own planet, reminding us that what happened on Mars is not entirely out of the realm possibility here on Earth.
So it's about understanding the potential consequences of climate change, the interconnectedness of planetary systems, and ultimately ensuring the long-term survival of our own species.
Precisely. The story of water on Mars is more than just a fascinating scientific puzzle. It's a story that has profound implications for our understanding of life, the universe, and our place within it.
Yeah.
It's a story that's still being written, with each new discovery adding another layer of intrigue.
You've given us so much to think about, from ancient oceans and hidden glaciers to the tantalizing possibility of life beyond Earth and the future of human exploration. It's clear that Mars, despite its seemingly barren appearance, holds a special place in our collective imagination. This deep dive into the mysteries of water on Mars has been, well, it's been truly eye-opening.
It's been a pleasure sharing these insights with you and our listener.
And to you, dear listener, we leave you with this final thought. As we continue to explore Mars, uncovering its secrets and pushing the boundaries of human ingenuity, we're reminded that the quest for knowledge, the drive to understand our place in the cosmos, is one of the most defining characteristics of our species. And who knows what wonders await us, just beyond the horizon.